Dear students, last class we started about that transmission and distribution. Just we will go for that overview of our transmission and distributions. So yesterday we started insulators, cables, overhead lines, but we completed only up to insulators and cables. In the insulators, yesterday we saw about what is the definition and properties of insulators and the types and constructions of insulators, and how using your string insulator, how the voltage distribution is taking place, and based upon this we saw about testing efficiency, and also we showed that on important things how the methods of improving the testing efficiency. So these are the overview of insulator. Yesterday we saw it, and next we saw about our cables. In this cables we saw about underground cables, and as well as introduction of cables, construction of cables, types of cables. I think we stopped up to your capacitance of single core cable. So today we will see about that dielectric stress of your insulation capacitance. So today we are going to start about dielectric stress in the single core cable. First, please you go through your diagram. So in the diagram we are having that this middle part is nothing but your conductor, and this is your outermost part. So we have to consider here we are having only that one section of the part, that is inner and as well as what, outer. The same procedure how we started in that insulation resistance and as well as capacitance, the same thing we have to go through it. And this is your mechanical, and this is your dielectric strength. And in this dielectric strength we are having that two things, gradient. In the gradient we are having a maximum gradient and as well as minimum gradient. Please you should know it, the gradient it should be occur very maximum inside your conductor. So inside your conductor only the gradient is very, very high, and when you go for inner to outer, your gradient will be minimum. So what we are going to do in the dielectric stress now, we are going to calculate gradient, and based upon the gradients, what about your gradient maximum and what about your gradient minimum. So before that, please you see that theory part. Consider a single core cable with a core diameter small d. Please remember it. Your small d is nothing but what? Internal surface. And the capital D is nothing but internal sheath. Internal sheath, no, outermost surface. So outermost surface is nothing but capital D. Next, and this is your electrical insulation intensity of property x meters, and already we derived it. E of x is nothing but q divided by 2 pi x epsilon naught epsilon r. Epsilon naught is nothing but constant value, and epsilon r is nothing but relative permittivity. According to your electric density intensity definition, it should be equal to your potential gradient. That's why here we are written G is equal to E of x. So this is very, very important. Please you make a note. This is very, very important. Your potential gradient G at a point of x meters and the cable center of the cable, G is equal to E of x. We know the E of x from the equation 1. We have to substitute here. So G is equal to Q divided by 2 pi x epsilon naught epsilon r. So based upon the second equation, we are going to derive it gradient maximum and gradient minimum. How we can do it? It's very, very easiest one. Please you go through that equation. In the equations we are having q divided by 2 pi x epsilon epsilon r. So here we are going to change that x value. We have to change that x value. So how we are going to change that x value now? We can see the next slide. So this is your potential differences between your conductor. So we know the formula V is equal to Q. So from this easily we can calculate your Q. So your Q value is 2 pi epsilon naught epsilon r capital V log base C capital D divided by small d. Please once again, please you remember it. Capital D is nothing but outermost sheath, and small d is nothing but internal sheath. So now you have to substitute here. So you will get it G is equal to V. Please see the equation number 4. G is equal to V divided by X log E capital D divided by small d. So it's very, very easiest one. Next, it is clearly observed from the equation, that is potential gradient varies inversely as a distance x. Already I saw it here. I think you saw it in equation number 1. This is the gradient. I said it Q divided by 2 pi x epsilon naught epsilon r. And I very clearly I said it, your x, you have to vary the x. If you vary the x, automatically we can find out your gradient. So let me see it, how it will be occurring. Already I said it from the diagram. Please you go through the diagram here. In the diagram, we are having the two important radius, that is a small d by 2 and as well as what? Capital D by 2. I said it, small d by 2 is nothing but internal, and capital D by 2 is nothing but what? Internal to your external. So based upon this condition only, we are going to find out G maximum and G minimum. Let me see the equation. Please here, the potential gradient. Suppose if your potential gradient is will be very maximum now, at what condition? X is equal to small d by 2. If your potential gradient is very minimum now, at the condition X is equal to capital D by 2. So this small d by 2 and capital D by 2, already it was in the diagram. Already I said it. Now we have to just substitute this X value in that equation number 4. So if you substitute, see here, we know that gradient equation G is equal to V divided by X log E d by 2. So when X is equal to small d by 2, what is the G maximum? G maximum value is 2V divided by small d log E capital D by small d. And same thing, you have to substitute your X value capital D by 2, because we are having the two important thing, internal sheath and as well as what? Internal to external sheath. So from this only we are going to identify it. So we are having the G maximum and as well as G minimum. So based upon your dielectric stress, easily we can calculate your G maximum and as well as what? G minimum. Let me see the next topic, gradient. It's very, very important, gradient. So first you should know it. What is the grading of cables? Your grading of cables, the process of achieving uniform electrostatic stress in the dielectric of cables is known as grading of cables. Please listen. The process of achieving uniform electrostatic stress in the dielectric of cables is known as grading. So how you are going to do the grading of cables now? Two important methods we are having. One is a capacitance grading and another one is what? Inter-sheath grading. So based upon these two important methods only, we are going to find out your grading of cables. So let me see the next slide. So next slide, capacitance grading. Please all of you go through that your diagram. It's very, very important. How many layers we are having? Here we are having the 3 layers. One is that epsilon 1 and another one is epsilon 2 and another one is what? Epsilon 3. So here we are having the 3 different types of layer. Please remember, in the capacitance grading, we are having 3 different layers. So that's why in the diagram, they mentioned epsilon 1, epsilon 2 and as well as what? Epsilon 3. And same thing, this innermost circle is nothing but what? Your conductor. So that's why their distance is small d by 2. So from inner to epsilon 1, your distance is d1 by 2. Your inner to second layer, epsilon 2, your distance is small d2 divided by 2. And inner to your outermost sheath, your distance is capital D by 2. So normally in the insulation of resistance and as well as dielectric stress, we saw about only the 2 layers, but here we are having the 3 different types of layers. So please see the theory part. The process of achieving uniformity in the dielectric stress by using layers of different dielectric layers is known as capacitance grading. So once again, please listen. The process of achieving uniformity in the dielectric stress by using layers of different dielectrics is known as capacitance grading. As from the diagram, what they are clearly they are telling now, we are having the 3 dielectric stress and your outer diameter is D1, D2 and capital D. And as well as your relative permittivity, we are having the 3 layers. That's why we are keeping epsilon 1, epsilon 2 and as well as what? Epsilon 3. Next slide, we will see it. So already we are having that gradient equation. I think you're familiar with it. Q divided by pi epsilon naught pi epsilon 1. So here we are going to include the distance. The distance is small d, d1, d2. So here we are having the 3 layers. That's why we are finding 3 gradient. G1 max, G2 max and as well as what? G3 max. So now we have to equate all the gradient. Suppose if your gradient 1, gradient 2, gradient 3, it should be equal. You will be having the condition epsilon 1 d equal to epsilon 2 d1 equal to epsilon 3 d2. So this is the gradient part. Now as usual procedure, we have to find out what? Your potential differences. Potential differences is nothing but your voltages. I said it, here we are having the 3 different layers. So we have to calculate V1, V2 and as well as what? V3. So let me start from that inner layer. Inner layer, they are taking that capital V1. capital V1. So inner layer to the next layer. Your inner layer, we are having the radius. How much the radius we are having? Small d by 2. And next layer, how many radius we are having? D1 by 2. So that's why in the integral, lower limit is small d by 2 and upper limit is d1 by 2. So all of you clear? Please listen. Once again, I will tell this concept. It's very, very important. If you know this concept, then you can easily proceed V2 and as well as V3. Just to go through the diagram. In the diagram, we have to calculate your V1. V1 is nothing but inner to next. This is the innermost, inner to first layer. So inner layer we are having that the small d by 2 and next layer we are having what? D1 by 2. So based upon this only, here we written it. Small d by 2, d1 by 2. And gradient. Gradient, we know the formula, q divided by 2 pi x epsilon naught epsilon 1. So here what are the constant terms we are having? Q divided by 2 pi x epsilon naught epsilon 1. And while you integral it 1 by x, you will get it how much? Log e d1 by d. So now, based upon this concept, we are going to see about potential gradient in the second layer. That is second to third. Second layer, what is the radius we are having? D1 by 2. And third layer, what is the radius we are having? D2 by 2. That's why here we written D1 by 2 lower limit and D2 by 2 is upper limit. The same procedure, how you did in that V1, the same procedure you have to do it. And finally, you can get that answer. V2 is equal to q divided by 2 pi x epsilon naught epsilon 1 log base c d2 by d1. And the next, third layer to outer layer. Third layer, what is we are having? D2 by 2. And outermost layer is how much? D, capital D. So here, what is that concept now? Your integral limit will be different. If you go through that answer, your final answer V1, V2, V3, up to your q pi 2 pi x epsilon naught epsilon 1 is a constant. And the remaining apparent log e d by 2. So while you go for V1, what is the answer you are getting? Log e d1 by d. And V2, what is the answer you are getting? Log e d2 by d1. And what is the V3? You are having log e d by d2. That's all. So here we are having the three layers. So we found out V1, V2, V3. And next, this is your potential differences between your core and your earth sheath. So your answer, I think this condition, you know it. Capital V is equal to V1 plus V2 plus V3. So while you substitute all the V1, V2, V3, easily you can get it your voltage. So this is called your capacitance grading. Please remember it, ma. Your capacitance grading, you are having the three different layers. And epsilon 1, epsilon 2, epsilon 3 is nothing but what? Three different types of relative permittivity. So based upon this, we calculated V1, V2, V3. So next we will see it. Intersheath grading. Can you tell what is the difference between your intersheath grading and capacitance grading? It's very simple. In the intersheath grading, all the layers are same. All the layers are same. But what is the main differences between your capacitance and intersheath? In the intersheath grading, the lead, see here, the blue round circle. The blue round circle is nothing but what? Lead. Here, your lead is different. Your lead is different types of material. Please remember it. In the capacitance, what is the concept? Three different layers you are having. But in the intersheath grading, the layers are same, but we are having what? Three different types of your lead. That's why here, see the diagram. Here, they are mentioning intersheath 1, intersheath 2, and outermost is nothing but what? Lead sheath. The same concept. In capacitance, what you did? Inner layer to outer layer, first layer to second layer to outermost layer. So likewise here, intersheath 1, intersheath 2, and the outermost layer is nothing but what? Lead sheath. So this is the basic concept of between your capacitance grading and as well as what? Intersheath gradings. So please, you see the definition. Easily you can understand. In this method of cable, a homogeneous dielectric is used, but it is divided into various layers by placing metallic intersheath. It's very, very important. By placing metallic intersheath between the core and lead sheath. Let me see it. So the same thing, we have to derive it. Consider the core cable. Inner diameter how much? D. And outer diameter was, outer sheath is what? Capital D. And inner sheath diameters you are having D1 and D2. And outermost is nothing but what? Inside the homogeneous dielectric maintained. And here also we have to find out what? Three different types of voltages. V1, V2, V3. Let me see the solutions. And already we are having that the maximum gradient equations. So based upon this equation, we are getting G1 max, G2 max, G3 max. So homogeneous is nothing but we have to equal all these things: G1 max, G2 max, G3 max, and as well as what. Finally, you have to give it G max. So this is your final solution of your intersheath grading. So next topic. So that's all about your cables. So cables, we finished it. And next is it is very interesting topic: mechanical design of overhead lines. OH is nothing but what? Overhead lines. So first of all, you should know it. So what do you mean by overhead lines? Overhead line is nothing but what? The cables which should be connected in the upper part, overhead. So overhead lines, what are the difficulties will come now? We will see it. So this is the overview of overhead lines. Mainly in the overhead lines, we are having sag. We are having what ma? Sag, SAG. And based upon this sag, we are having the two important divisions. One is support at equal and another one is support at unequal levels. So please remember it, ma. In the overview of overhead lines, the important point is what, ma? Sag. How you are going to calculate your sag now between your two important equal and as well as what? Unequal levels. And based upon your equal and unequal levels, the final topic is stinging chart. So this is the three important overview of overhead lines. Let me see what is the sag. So this is the sag. I think easily you can understand. What is the sag? Please you see the diagram A and B. We are having A and B. We have to consider the supports. So two supports, A and B. A and B as what? Equal in support. So this is your transmission line. The transmission line is bending. The transmission line is what, ma? Bending. In the lower part, this lower part you have to consider is O. So the distance between A and O is nothing but what? Yes. This is called what, ma? Sag. Sir, you may ask, sir, we have to calculate only A to 0. Can't we do it for B to 0? You can do it. B to 0 is O is also what? It's a sag. But why we are not considering B to O? Here we are having that equal support. A and B is what, ma? Equal support. So in the equal support, it's your wish. If you want to take A to O, you can take it. No, sir, I'm going to take only B to O. Okay, fine, do it. B to O, you have to take it. So the distance between your A to O is nothing but what? Sag. So please remember it. This A and B are equal supported. So see the definition. It's very important, ma. The difference in level between points of supports at the lowest point on the conductor. So this is your lowest point of the conductor is called what? Sag. Okay, well. So let me see it. What is the calculation of your sag? Calculation of your sag. I think you know the concept. How the sag is occurring? It's very easiest one. Due to that conductor weight. If your transmission weight, if your transmission is more weight, it will be what? The sag will be, the bending sag will be come. Or at the time of wind, or at time of ice loading. Ice loading is nothing but what? If you go for your Jammu and Kashmir, the transmission line, it should be fully coated with what? Ices. So due to these parameters, the sag will come. The sag is nothing but what? Bending. Bending of your transmission line from one part to another part. So due to this reason only, we are having that sag. So we have to measure the sag. So to measuring the sag, we are having the two important methods, equal levels and as well as what? Unequal levels. It's very important question, ma. Equal level and unequal levels. First, we will see about supports or at equal support. Please listen. Whenever you are using that support, you should directly consider what? A and B. Please remember it, ma. Whenever, if you are going to see about that word support, support is nothing but here. How many supports here? A and B. Only what? Two supports are there at equal levels. Equal level is nothing but what? A and B was what? Same line. That is nothing but what? Equal level. And we have to make that sag lowest part. This is your, see the diagram. This is your lowest part. This is the sag. Okay. And next, I think now you can understand. When you go for the definition of the sag, we taken to A to O. Correct? Now what we are taking here? B to O. So it's your wish. When your supports are at equal levels, you can take the sag from A to O or B to O. So here we taken what? B to O is a sag. Okay. Now we have to mention that a point P. This point P is also, it's your wish. If you want to keep it here, you can keep it. Or if you want to keep it here, you can keep it. So this is the point we are giving that assumption here, point P from in between your B and O. Can anyone tell what is a function of the, what is the denotation of that T? T is nothing but tension. T is nothing but what ma? Tension. And W is nothing but what? Weight. So tension, I think you know it. Suppose in that sag condition, if the wind is blowing from position of B, what will be happen? The sag is moving from this place to this place. So that is a what? Tension. And the tension, how is it occur na? Your weight of your transmission line. Your weight of your transmission line. So that's why here we are having the two forces are there. One is from torque and another one is what? Weight. So we have to equate these two torques, two forces. Then easily we can calculate your Y and as well as what? Sag. And in the P, we have to make the coordinates. Coordinate is nothing but axis. See the diagram. O to P, it is nothing but what? X. And P to O is nothing but what? Y. So your P point having that two coordinates. One coordinate is X and another coordinate what? Y. Sir, what is that X by 2? You can ask. The X by 2 is nothing but what? Over length. But we are taking only the weight. In the weight, what is that? Here we are denoted na. So from this O to W is nothing but what? X by 2. I think now you can easily clear the concept. Once again I will tell. Listen carefully, ma. AB is your two supports. Okay, va? Your overall support is nothing but length. Overall support is nothing but what, ma? Length. So we may be called as length of the span. Length of the span. So according to your sag O, your length is can be divided into two parts. One is L by 2 and another is also what? L by 2. Have you understand? And this is a O. O is nothing but what? A sag, lowest position. From the lowest position, the tension will be occur. How the tension will be occur now? According to the weight of the conductor from B to O. So in this part, in the lower part, we are having the two forces, or you can tell it two torques. So now we have to equate the two forces. Then easily we can calculate your sag. And X and Y is nothing but coordinates of your P. I think everyone, you can clear the concept of your sag at equal levels. Now we will go to the next slide. See the next slide. I think this is that theory part. Just now only we saw it. Consider a conductor between two equal level supports, A and B. So it is what, ma? Two equal level supports, A and B. And O is the lowest part. From the diagram only, we are taken all these thing conditions. Let L, I said it. L is nothing but what? Length of the span. Next, W. W is nothing but what? Weight per unit length of the conductor. T is nothing but what? Tension of the conductor. And this P point, we have to make the assumption. That's why we are telling here, consider a point P on the conductor. And from that, we have to make the coordinates. That is the origin. It is nothing but what? For P coordinates, we are having X and Y. So now, based upon these data, we are going to solve about your sag. See here, already I said na, we are having that two forces in the portion of OP. One is a tension and another one is what? Weight. So part A, please see it. The weight Wx of the conductor acting at a distance X by 2 from O. And next B, your tension T is acting from the O. So please remember it. In the sag, that is the lowest part of your sag, you are having the two forces. One force is nothing but from that tension, and another force is nothing but your weight of your conductor. Now we have to equate these two things. Now we have to equate these two things. So while you equate this thing, please you go through that diagram. T. So equate torque. Your Ty is equal to, next is what? Weight Wx into X by 2. Ty is equal to Wx into X by 2, or you can write it Wy is equal to Wx square divided by 2t. So once again, I will tell this equation. How we can write this equation, I will tell it. Please listen. Here we are having that two types of forces. One is from the torque and another one is from that your weight. So we have to make this. So this is what? T into Y coordinate. And next is what? Wx into X by 2. Or we can write it Y is equal to Wx square divided by 2t. Now next, your maximum dip, that is nothing but the sag we have to calculate. Already you are having that length of the span. Your length of the span is nothing but what? Total L. This total L is divided into two parts, L by 2. So it's your wish. You can solve it in the terms of support A, or you can solve it in the terms of your support B, because it is a equal level. To finding the sag, please listen carefully, ma. To finding the sag, it's your wish. You can make it, you can take it either any one of your support at A or B. So here I'm taken that support A. Support A. Support A, what is that? X is equal to L by 2. And Y is nothing but what? Sag. This is the assumption value. I'm going to substitute in the above equations. So Y is nothing but what? S. W. X is nothing but I'm varying it, L by 2. So Wx square divided by 2t. So I'm substituting here. So this is your final answer. So your sag for equal position, your answer is S is equal to WL square divided by 8t. Please remember it. This sag is applicable only for equal position. Next we will see it, unequal levels. I think from this diagram easily you can identify it. Where it occurs only to the hilly station, mountains, only hilly stations, because one pole we have to keep it lower and another pole it should be what, high. So this unequal levels, it should be applicable only for your hilly station. While it is applicable for hilly station, it is very difficult, because difficult to identify for your sag, because in the equal level, please see the diagram, equal level easily we can identify your sag is in between your A and B. But in the unequal levels, your sag, it should be occur in the lowest part. That is what, the lower pole. Lower pole is what, A pole. So in the A pole only the origin of your sag will be occur. So in the equal levels, it is, we don't worry about thing. Your sag is the middle of your poles. But in the unequal levels, your sag will be occur in the lower pole. That is a A. So automatically what we are having, the two types of sag. One is S1, that is A2O, and another one is B2O. And A2O, B2O, already that thing also I said it to you. For equal levels, it's your wish. You can identify either A2O or B2O, because it is an equal level. But here it is an unequal level. So you should calculate both S1 and as well as what? S2. Ma, please all of you give that feedback, ma. Please all of you give that feedback. Students, please all of you give that feedback, ma. Students, please give your feedback. Okay, ma. Let me start from second one. When support are at unequal levels. So last slide, last topic, we saw about when support at equal levels. Now we are going to see about supports at unequal levels. I think you know it. From the diagram easily you can observe it. So this is applicable only for the hilly stations, mountains. So while you construct that poles in the mountains, one end it should be the lower part and another end it should be your higher part. So automatically your sag it should be belongs to your lower part. And please remember it, in the equal levels you can find out the sag any one position, A to O or B to O, but in the unequal levels you should calculate the sag in both the part, A to O and as well as what, B to O. So that's why in the diagram it is mentioned S1 and as well as S2 here. And height between your what, B and A, height between. So you have to mention, you have to identify what is the height of your pole for, that is A to B, and the length of the span is L, and they divided here A to O to X1 and B to O is X2. So we are differentiated. So let me see the next slide. Okay, as I said it, in hilly areas, we are generally come across your conductors suspended between your unequal levels. And figure A. So this slide, based upon your diagram only, we are written here. Let L be the span length and H is the differences in level between two supports, and X1 is nothing but support at lower level. Lower level, please listen. Here I taken what? A to O. And X2 is the distance of higher level. Higher level, please see the slide, ma'am. Its mention is what? B to O. And T is nothing but a tension. So this is the parameters of your unequal levels. Now, based upon these parameters, we are going to calculate your sag. Please remember it. In unequal levels, you have to calculate the two sags, S1 and as well as what? S2. Let me see it. Next, W is the weight of that unit length. Your weight of the unit length. Then we have to calculate your sag. Already I said it. Here we are having the two support A and B. So you have to calculate S1 and as well as what? S2. So please see the slide, ma'am. In support A, X is equal to X1. So this is from diagram only I am taking. A is equal to what? X1. B is equal to what? X2. So that's why written here. X is equal to X1 and Y is equal to S1. Normally in previous derivation, what we taken now, Y is equal to S. Here we are having the two sag. That's why we are mentioning at lower part is S1 and upper part is S2. That's why we are mentioning Y is equal to S1. And while you substituting these values in that equation, you will get it S1. Please see the equation number 1. W X1 square divided by 2T. That is equation number 1. And next, support at B. The same concept. Support at B now, what is that? Please go to the diagram. Support at B. What is the distance here? X2. So that's why I am keeping here what? X2. And Y is equal to what? S2. Sag S2. So while you substituting, you will get it 1 and 2. So now you have to calculate your S1, S2. How you are going to calculate? So first we have to calculate X1 and X2. If you are finding out X1 and X2, easily we can calculate that sag at position A and as well as sag at position B. So let me start. What is the procedure? How we have to calculate your X1 and X2? X1 is nothing but a distance from A to O. X2 is nothing but what? Distance from B to O. See the third equation. In the third equation, we know it. Length, your overall length. See the diagram. Your overall length. The overall length, it is split into X1 and X2. So shall we write like this? L is equal to X1 plus X2. So X1 plus X2 is nothing but what? L. And we are having equation number 1 and 2. So we have to subtract it. I will tell why we have to subtract it in the next slide. So you have to subtract it S2 minus S1. So while you subtracting S2 minus S1, see the second equation, you will get it. S2 minus S1 is equal to W divided by 2T. Here, this W is nothing but weight of the conductor and T is nothing but tension of your conductor. And while you solving this, you will get it X2 square minus X1 square. It should be in the form of A square minus B square. I think you know it. You are familiar in the mathematics. A square minus B square. A plus B into A minus B. See the third equation. S2 minus S1 is equal to W divided by 2T X2 plus X1 into X2 minus X1. Now, what we are going to do it? Already we know that x2 plus x1. x2 plus x1 is what? L. See the equation number 3. So just you have to substitute. Your final answer is s2 minus s1 is equal to wl divided by 2t x2 minus x1. Let it be equation number 4. And from the diagram, I said it now, we have to subtract s2 minus s1. Why you have to subtract? Because to find out your height. Because to find out your height. See the diagram, your height. This is your height. In the height, you are having what? S2 and as well as S2, S1. If you finding the differences between your S2 and S1, easily you can calculate what? H. So this process is taking place here. From the diagram, S2 minus S1 is equal to H. Now you have to substitute in the above equation. So you will get it x2 minus x1, equation number 5. So now you have to compare it. How you have to compare it now? Already in equation number 3 we are having, what is that? x1 plus x2 is equal to L. So now you have to add 3 and 5. While you add 3 and 5, you will get it x1 and as well as what? X2. Understand? X1 and X2. Now easily you can calculate. If you finding your x1 and x2, you can substitute in equation number 1 and 2. So easily you can calculate your sag1 and sag2. So this is the concept of your unequal levels. Very easy. For equal level, you have to calculate only the one sag. For unequal level, you have to calculate your two sags. And one more important thing, your unequal level, where it applicable now, it will be applicable only in that hilly stations. Okay. So based upon this concept, we derive the derivation for sag at support at lower equal level and as well as what? Unequal level. Now based upon this, we will solve that two problems. Problem in sag. Please go by line, go with line by line. A 132 kV transmission line has the following data. Here the data is directly they given it. Weight of the conductor 680 kilogram per kilometer. Length of the span 260 meter. Next ultimate strength 3100. And next safety factor 2. What they are asking, calculate the height above the ground at which the conductor should be supported, and also ground clearance required is 10 meters. So can you identify it? Can you anyone tell it? What type of problem is there? It is nothing but equal support. The sag with what? Equal support, because they not mention A and B. What is that A height and what is the B height? They not mention it. So we have to take it. This is what? Equal level. So solution. We know that directly you can write that sag formula. What is the sag formula? S is equal to W L square divided by 80. W L square divided by 80. And L is nothing but what? Length. So length of the span is what? 260 meter. W is nothing but what? Weight of the conductor. Weight of the conductor, already they given what? 6080, I think so. Yeah, 680. 680 they given it. So you have to divide it by 1000, you will get it what? 0.68. But please see the question, the formula T. T is nothing but what? Tension. Any data is given for tension? No. There is no data for tension. Then how will you calculate that tension value? So in the question, they directly they given two datas. See here, ultimate strength and as well as what? Safety factor. If you divide these two things, you will get it your tension. See here, working tension is equal to ultimate strength divided by safety factor. So don't worry about it. Suppose this kind of question in your examination, if they ask, no, don't worry about it, the tension is not given it. So instead of tension, they given that two indirect values, ultimate strength and as well as what? Safety factor. If you divide both the things, you will get it what? Tension. So tension is 1550 kilogram. Now, now you can get it W, we know it L, we know it what? T. So directly you substitute in the sag formula, you will get it. Sag is nothing but 3.7 meter. Okay, so one part is finished. And another part in the question they given it. Please see the question, last line. Please go to the last line. Ground clearance is required is 10 meters. So ground clearance we have to need. We have to do it. So the hint they given it what? 10 meters they given it. So conductor should be supported at a height. So already the ground clearance they given it what? 10. So 10 and the sag is 3.7. So 10 plus 3.7 is nothing but what? 13.7 meter. That's all. So this question is very, very easy. I think in your examination, if they are asking that sag problem with equal support, easily you can do it. Okay, let me solve that the next problem. Next, I think from the diagram, easily you can identify it. What type of a question this one? Unequal levels. Very good. Unequal levels. So in the unequal levels, please you see the question. The towers of height 30 meter and 90 meter. It is marked with red color. The towers of height 30 meter and 90 meter. So here two height they given it 30 meter one and another one is what 90 meter. So automatically from the first data easily you can observe it is what unequal levels. And support the transmission line, horizontal distance, the distance between the tower is also the what they given L, length of the span is also what given it 500 meter. Next, if the tension of the conductor is 1600 kg, find the minimum clearance of the conductor and water. And the next question is clearance midway between the supports and weight of the conductors they given it. Okay, so from the first line itself easily we can identify this question is belongs to what unequal levels. Let me see it. Solutions. Supports A and B at different levels. How we are telling it different level na? According to the question, the towers of height 30 meter and 90 meter, and length of the span they given it 500 meter. Weight of the conductor is given it 1.5 kilogram, and the tension is nothing but what 1600. So here I think the tension that directly they given that, so you need not to worry about this thing. So T is equal to 1600 kg. So now we have to find out your H. Already H formula we know it. What's the H formula? Height. So 90 minus 30. So 90 minus 30 is nothing but what? 60. 90 minus 30 is nothing but what? 60. And from the diagram, see the equation number 1. X1 plus X2 is equal to what? 500 meter. So this equation number 1 we are taken from the diagram. So diagram, what is the total length? The total length is what? 500. So 500 is nothing but X1 plus X2. We know that for unequal sag levels, we are having the two equation. S1 is equal to Wx1 square divided by 2t, and S2 is equal to Wx2 square divided by 2t. So our ultimate aim, we have to calculate X1 and X2. Once if you finding about your X1 and X2, easily you can calculate your sag1 and as well as what? Sag2. So next slide we have to see it, how we have to find out your X1 and as well as what? X2. So from the diagram, is nothing but what? Your main diagram. H is equal to S2 minus S1. Substitute your H values S1 and S2 in the above equations, and you can get it what? X2 minus X1. H is equal to WL divided by 2T X2 minus X1. Okay, so from this we are getting what? X2 minus X1 is equal to 256. Already you are having that one equation 1. What's the equation 1 says? X1 plus X2 is equal to 500 meter. Equation number 5, what is say? It is nothing but what? X2 minus X1 is equal to 256. Now we have to equate equation number 1 and 5. Just you have to add it. Well, you add what is, easily we can calculate what? X1 and as well as X2. So X1 is 122 meter and X2 is nothing but what? 378 meter. Next, substitute. So this value you have to substitute in your sag S1 and as well as what? S2. So while you substituting, you will get it S1 is equal to 7 meter, and likewise same thing S2, you will get that answer. But why we not find out the S2 here now? They given that one important thing, the clearance of the lowest point O. Your lowest point O is belongs to your what? A position. That's why we calculated only S1. Suppose if you want to calculate, if you are finding out that S1, no problem, leave it. So why we are particularly in this problem, why we are considering only the S1 now? According to the question, please listen this question. Clearance of the lowest point O. Lowest point O is belongs to what? A, pole A. So that's why we are considering only that S1. So level is 30 minus 70. 30 already we are having. How we are getting the 30? 90 minus 30 what? 60 meter already we are having in the data. So 60, 30 minus 7. So 30 minus 7 is nothing but what? 23 meters. So this is your lowest point O from water level. And next, lead. The midpoint P. This midpoint is nothing but, see the question ma. Clearance midway between the supports. So we have to find out your midway. Middle part. Midway is nothing but what ma? Middle. In the middle we have to find out X from the lowest point. So we are having the total length. The total length is nothing but what? 500. So this 500 is divided by 2 is nothing but what? 250 here. So capital X is equal to 250 minus x1. X1 just only we found out 122 meters. So you have to substitute here. You will get it what? 128 meter. And sag mid. The formula is everything is same. Just we are including what? Mid. That's all. The formula is same. S is equal to Wx divided by 2 square. The same formula. Here we are going to find out the mid position. That's why we are calculating what? Mid. So S mid is equal to Wx square divided by 2t. Just now only we calculated your x. 128 meters. 128 meters. So weight is W is nothing but what? Weight of the conductor. And T is nothing but what? Tension of the conductor. So X already we found out 128 meters. S mid is equal to 7.68. While you substituting S mid is equal to 7.68 meter. So you have to substitute here clearance of the midpoint P from water level 23 plus 7.68. So you will get it what? 30.68. This 30.68 is that midpoint clearance of your water level. So that's all about your sag unequal levels. Finally, you are going to calculate your stinging chart. Finally, we are going to calculate your stinging chart. So how will you calculating your stinging chart now? Already in the sag, we are having what that? Sag and as well as what? Tension. Sag and as well as what? Tension. So based upon this sag and tension, we are draw that temperature stinging chart. So stinging chart is nothing but for use of the field work of the stinging, the conductor temperature, sag and temperature tension chart are plotted for the given conductors and loading conditions. Such curve is called what? Stinging chart. So that's all about your overhead. That's all about your overhead line.